Hi everyone, welcome back to another video. So we're continuing on in the trigonometry chapter in the K.A. Stroud Engineering Mathematics book. We did the first part of the trigonometry chapter review in the last video. Now we're moving on to the trigonometric identities. So let's get started. The fundamental identity: given the right angle triangle of the figure with vertices A, B and C, sides opposite the vertices of A being hypotenuse C and angle theta at B, then A squared plus B squared is equal to C squared. This is basically just going over Pythagoras' theorem again. And then he jumps in and says, dividing both sides by c squared gives us a over c squared plus b over c squared is equal to 1. That kind of just flies out of nowhere. And the first time I read this, I didn't have a clue what he was talking about. Okay, so I'm going to read on to the next bit, and that will make more sense as to why this equals 1. And then we'll break it down a bit further. So don't worry if you're confused here. So because a over c, so we're talking about a over c, is equal to cosine, right? Because obviously that's the adjacent over the hypotenuse, which if you remember saw TOA, right? Then you know that that's obviously cosine there, adjacent over hypotenuse. Okay, so because a over c is equal to cosine and b over c, which is sine, right? Opposite over hypotenuse is equal to sine theta. This equation can be rewritten as cosine squared plus sine squared is equal to 1. So this is what we've got to take away from this. So must remember. So from this video, this is what you want to take away. You just memorize this. Cosine squared plus sine squared is equal to 1. So if you're like, how? Let's go through it. Okay, so let's remind ourselves. Sine of theta, or sine of any angle, is what? The opposite over the hypotenuse, right? And likewise, cosine of any angle of theta is equal to what? Adjacent over hypotenuse. Should be comfortable with that. So what happens if we squared both of them? The sine of theta squared and cosine of theta squared. What do you get? You get opposite over hypotenuse, and then you can just square them both like that. Likewise here, you get adjacent over hypotenuse. You can just square them both like that. You'll see why that's important. So remember Pythagoras' theorem, right? So what would happen now if we added these two together? So for example, do this. Sine of theta squared plus cosine of theta squared. And what does it equals? Well, you're basically just taking these two, right? And you're just adding them together. Okay? So sine of theta plus cosine of theta is equal to the opposite squared over the hypotenuse squared plus the adjacent squared over the hypotenuse. So we can simplify this equation here, obviously by just combining these two bottom terms and then adding the 2 on top and leaving it like that. So we can say opposite squared plus adjacent squared all divided by hypotenuse squared, right? Another way that you'd see this written is, right, in different color, a squared plus b squared all divided by c squared, because they're taking a to be the opposite, b to be the adjacent, and c to be the hypotenuse, which is generally the convention, right? Okay, so here, let me write this out in a different color. What you want to do is you want to remember the Pythagorean can't spell it, theorem. Pro tip: when I was in school, this is what we used to do. Whenever we couldn't spell a word, I don't know, let's say if it was, I don't even know, hexadecimal. If you couldn't spell it, you'd just write hexadecimal like that. Mate, you knew it ended in an L. You put a big H there, maybe chuck in an X there, and there you go. You just be like, yeah, kind of right. And that actually used to work in school. Anyways, I digress. Okay, so remember Pythagoras' theorem, right? So a squared plus b squared is equal to c squared. Okay, so that basically means opposite plus adjacent, opposite squared plus adjacent squared is equal to the hypotenuse squared, right? That's what we're saying. Whenever we say a squared plus b squared equals c squared, what we're saying is the opposite squared plus the adjacent squared is equal to the hypotenuse squared. Okay, so in this instance, the opposite is a, the adjacent is b, and the hypotenuse is C. So I'm going to switch over to A, B, and C now, but just bear in mind that behind those, the meaning behind that A, B, and C is actually the opposite, the adjacent, and the hypotenuse. Okay, so if A squared plus B squared equals C squared, and what we're saying is that opposite squared plus the adjacent squared is equal to the hypotenuse squared, then going back to this equation here and duplicate it, right? We can just write, for example, A squared, B squared equal to C squared. That's what we're saying, right? Okay, so we've just said that opposite plus adjacent, opposite squared plus adjacent squared is equal to what over here, right? We said it's equal to the hypotenuse squared. Therefore, this entire equation could be rewritten as either hypotenuse squared divided by hypotenuse squared, or we could write it as C squared divided by C squared. So if I take U and divide U by U, what do you get? U. If I take 16 divided by 16 equals 1. Whenever you divide something by something or something by itself, you get 1. So hypotenuse squared divided by hypotenuse squared, or C squared divided by C squared, is equal to 1. And so going back to how we ended up here, sine squared plus cosine squared is equal to 1. It was basically a super long-winded way of writing that. Cool. Okay, so keep this in mind. Cosine squared plus sine squared is equal to 1. Okay, and I assume it's going to go into... Okay, so where the notation cos squared theta is the same as cos theta squared. So you could write it like this, or you could write it like that. That's fine, right? And the same thing with sine. So since this equation is true for any angle theta, the equation is in fact an identity. The cosine squared plus sine squared is 1. That's what it's saying. So it is 1. That's fine. And it's called the fundamental trigonometrical identity. I'm not sure where the author got this from. I tried to Google this. I know there's a bunch of fundamental trigonometrical identities. Why this one is called the fundamental trigonometrical identity, I don't know. If you know, leave a comment below. Okay, so let's carry on. So for example, to show that the triangle with sides 3 centimeters, 4 centimeters, and 5 centimeters is a right angle triangle, it is sufficient to show that it satisfies the fundamental trigonometrical identity. That is, taking the side of length 3 centimeters to be adjacent to the theta, side of length 5 centimeters, obviously the hypotenuse, as it is the longest side. Okay, so then cosine is equal to 3 over 5. Yep. And sine is equal to 4 over 5. And so cosine squared plus sine squared, and then they're working out. So you're taking these two and squaring them, and that gives you 9 over 25 plus 16 over 25. Add those two together, and that gives you 25 over 25. Something divided by itself is always equal to 1, right? So they're just proving that this triangle here matches with this. Okay, so they've got a question for us to do. So is triangle with sides length 8 centimeters, 12 centimeters, and 10 centimeters a right angle triangle? So we can just apply this here. What we can say is you can say 8 centimeters, 10 centimeters, and 12 centimeters. And we're saying, is this a right angle triangle? So let's work it out over here. Do that in short. So we've got cos squared plus sine squared is equal to 1, right? So cosine is 8 over 12, because it's the adjacent of here over the hypotenuse. And we're saying we're going to square that. And then sine is 10 over 12, right? And we're saying again, we're going to square that. And that's going to be equal to 1. So we're checking if this answer, this side here, is equal to 1. If it is equal to 1, then it is a right angle triangle. If it isn't equal to 1, then it isn't a right angle triangle. Cool. So square 8, that leaves you with 64. Square 12 leaves you with 144. Square 10 leaves you with 100. Square 12 again, 144. And then does that equal to 1? No, it doesn't. Why? Because you've got 164 over 144. And that, my friend, does not equal 1. Cool. So as you can see here, the answer is no. and then the final explanation. So because letting cos, yeah, and exactly what we've just done, 8 over 12, 10 over 12, adding them together, multiplying them out by get rid of their squares, and you can see 164 over 44 does not equal 1. And then so it rounds off the chapter by saying, rounds off this exercise by saying, since the fundamental trigonometric identity is not satisfied, this is not a right angle triangle. Cool, well done guys. Alright, I shall see you in the next video. We're just going to be cracking on through going on to the next trigonometrical identity. So I'll see you in that one. Hope you enjoyed it. Leave a like if you did. Peace.